So today we're going to look specifically at drawings for large assemblies. My name's Craig Stevens. I'm an applications engineer, field engineer with Intercad, and I'm certified SolidWorks expert and certified for data management with PDM Professional. This is the third part in this series that we're rolling out across this calendar year on large assemblies. Today is drawings for large assemblies, as I've mentioned. The first two parts cover hardware and managing parts and sub-assemblies. The fourth part will cover tools and tips for large assembly modelling. And as I mentioned, today's webinar is recorded. It should be up on my Intercad sort of within 24 hours from completion of the webinar. Alright, so moving on to today's agenda. The four main areas that I want to look at today are drawing load sequence, drawing performance, draft quality and high quality views, and then some settings and tips that we can use to improve the performance. Drawing load sequence covers how SolidWorks loads information into the drawing. The drawing performance will cover factors which have an influence on drawing performance as a result of that load sequence. We'll have an in-depth look at high quality and draft quality views and how they can affect the performance specifically. And then finally, settings and tips. We'll have a look at some other tools that will help mitigate some of those potential performance issues. And then I'll draw some conclusions at the end of what we've looked at today. Okay, so kicking off with the drawing load sequence. The diagram on the right hand side of the PowerPoint there shows the assembly load sequence and then the drawing load sequence. If I was to draw a line diagonally across the page there, the top left hand side is the assembly load sequence and the bottom right hand side is the drawings loading sequence. And so what this is really indicating is that every time you open a large assembly drawing, you're in fact opening the assembly as well. And as such, if your large assembly is not performing, your large assembly drawing will also suffer in terms of performance as well. And subsequently, anything that we've talked about in parts 1 and 2, best practices that improve the assembly performance, should also improve the drawing of a large assembly as well. The drawing load sequence itself, it's a similar process and can have similarly long wait times, particularly if you're updating. I've made a note there about configurations. I haven't really talked about these in the last two parts, but configs can have an impact depending on how much configuration data has been included in the assembly model, and also subsequently the parts. If I just bring up the SolidWorks screen, just wait for that to come up. Okay, so if we have a look at some of the drawing views here, if I right click and look at the properties, you'll see that this particular view is using a default configuration. Have a look at one of the other views and go to its properties, you'll see that's using a different configuration. If I drop down the configuration drop down there, you'll see that there's a number of different configurations specified in this assembly model. For each one of those configurations, it needs to have the configuration data available in the assembly to populate that drawing view. So the more configurations per view, per drawing sheet will increase the amount of time it needs to build that drawing up. If I actually have a look at the model for this, again you can see the different configurations here. One of the great things that we're able to do now in SOLIDWORKS is actually specify what configuration data we want available. If you have a look at the configurations that are specified here, 2 of them have a check mark next to them. What that indicates is that the configuration data is available for those specific configurations. The one that's got a dash next to it indicates that that configuration does not have its data currently available. It needs to be rebuilt effectively, and you can do that simply by clicking on that configuration, and it will rebuild that. Don't worry too much about that warning sign. There are some issues in that model, but it should actually show a green check there when it's rebuilt. So if I just go back to my default, we can control the configuration data. You can add a rebuild or a save mark. If I do that, you'll see that there's a disk icon that appears next to that particular configuration. What that tells me is that whenever I save, it will rebuild and make available that configuration data there. If I go to the top level of that particular configuration, you'll see that we've got options under the rebuild and save mark menu there. I can add a mark to this configuration. We've already got one there. I can add a mark to all configurations from this menu, or I can add a mark for specified configurations only. And then the 4th option is to remove and purge all of the data for all configurations there. So I can go away and make that disappear for all the other configurations except for the ones that have got issues there. And if I go back to my cutaway, that will rebuild that. Obviously it's got the warning icon there again, but don't worry too much about that. I guess the long and the short of it is that for every drawing view you need to have that configuration data available if it's shown on the drawing sheet. Otherwise you're going to run into the trouble of having to wait for rebuilds. So just coming back to the PowerPoint now. And having a look at the chart on the right hand side again, you'll notice here that the draft quality views and the high quality views are actually solved in parallel in that process. And this is done by multi-threading in SOLIDWORKS. So this is one of the occasions where SOLIDWORKS will use multiple cores to parallel process both draft quality and high quality views on the drawing sheet. The other note to make there is that this requires multiple cores as opposed to hyperthreading. SOLIDWORKS doesn't use hyperthreading. So if you've got 4 physical cores on your CPU, then it will use those 4 physical cores to help update both the draft quality and high quality views. In the draft quality flow there, it'll also solve dependent views like section views as well. And then the final part of that process is to rationalize layers and line fonts to display final drawing views. Okay, so that's where the high quality and draft quality come back in at the end of that process. And I guess the question needs to be asked, how would this affect my future assembly planning? Because obviously the more detail you've got in the assembly and the bigger the assembly is in terms of its parts and features, the more impact it's going to have on the performance. And for large assembly drawings, performance is going to be more important perhaps than what it is at the actual assembly level. So some things to consider there. So then, what are some of the drawing specific factors that affect performance on the drawing sheet? Just wait for that to refresh. Okay, so these things are quite obvious. The number of drawing views, the number of section views, and the number of sheets you have on a drawing are all going to affect its performance. SOLIDWORKS doesn't have any specific limits. It's really related to the file size and the hardware, but my experience tells me that specifically for number of sheets, it's probably better to have less than more. So if you break up your drawings so that you have less sheets, then the performance is always going to be better. There's nothing worse than having a drawing that's got 50 sheets in it, struggling to open, and then it crashes, and then it becomes corrupt, and having to rebuild that. Whereas if you've got perhaps a number of drawings with less numbers of sheets, you're going to have a better chance of recovering and losing that information. Again here, numbers of configurations. There used to be a limit on that about 10 years ago. Now again, it's limited only by the size of the file and the hardware that you're running. Again, we've got some tools that we've just seen to manage configuration data, so configurations have become less of a concern, but they still do have an impact. The number of edges and faces in the model, there's no hard and fast information in the knowledge base about this. I have referenced some articles about numbers of views, section views and sheets, etc. About those limits, but for edges and faces, they're really a product of the model itself, and so there's no hard and fast limits set by SOLIDWORKS on those. Assembly section views. There's a note here about section views on large assembly models, and the best practice here is to use assembly cuts in configurations rather than putting actual sections in the drawing sheet itself. So using the section tool in the drawing. The reason is because section views are the most expensive in terms of view calculation time. It's got to create an assembly level cut across the model at the section line. It's got to generate the view based on the cut faces and the hatch if required, and each model update triggers a read calculation and a redraw on that particular drawing sheet. So yeah, the recommendation here is to use cuts in the assembly rather than in the drawing model, and an example of that in this model that we were just looking at previously. Just wait for that to refresh. Okay, so there is a cutaway configuration used in this assembly, and if we switch to the drawing sheet, you can see on the drawing sheet that that cutaway has been used as a section view. Now that's a pictorial section, but you can use the same technique to generate a genuine section view on the model, and it will create a whole lot quicker than trying to actually use the section tool from the view layout in SOLIDWORKS. Okay. Draft quality versus high quality. We'll have a bit more of an in-depth look at that on the next slide. So just switch to that one. Draft quality is obviously going to look worse on a drawing sheet, but it's going to load up faster. It's only referencing the tessellated shape or triangles that make up the overall shape or the estimate of the body. High quality views on the drawing sheet, as the name suggests, provide better graphical representation, but they will actually cause your performance to decrease. And the reason for it is that it's referring to the parasolid detail, the geometry and topology, which describes the whole model. And I guess some things to note about the differences between draft quality and high quality. Just bear with me. Is that there is a known issue where the SOLIDWORKS is unable to create the high quality view. You'll see an error pop up that says there was an error in creating precise geometry for the following drawing views. They may appear empty, and this is typically seen when we attempt to export DXFs or DWGs, or to save as a PDF. Because both of those export activities require high quality drawing views. And the reason that they don't generally export with regards to this error is due to bad imported geometry. So neutral CAD formats being imported into SOLIDWORKS quite often have faces that aren't healed properly or aren't repaired. I talked about this in one of the previous parts, yeah, they really need to be fixed up, otherwise you can see these types of errors when you're exporting to those two file types. And for large assembly drawings, you don't want to spend all that time loading up that drawing and then try and export something and go, it's not going to do it. The draft quality drawing view image is a raster graphics image. So if I just open up an example, okay, so just waiting for that to show up. What you can see there is a bitmap file. If I zoom that in, what you'll see there is that it starts to look blocky and jagged. The reason is because that's a raster or bitmap file. The drawing quality is not that great, and this is effectively what your draft quality views are when you're looking at them in SOLIDWORKS. They are a raster image. The high quality image, on the other hand, is scalable vector graphics. Let's wait for the refresh there, and I'll open up an example of that. Okay, so scalable vector graphics file format .svg opens up in Internet Explorer natively. If I use the zoom on this, you'll see that as I zoom, the quality doesn't degrade. If I just scroll across so I can see that a bit better. Specifically looking at the edges of that slide there, you'll see that the image quality hasn't degraded. It's not jagged in the same way that the bitmap file is. And this is typically how the high quality view is created. Alright, so let's close that one off. Another good question is, how do you tell if the drawing view on the drawing sheet is high quality or draft quality? Let's flick back to the drawing and have a look at that. If I drop my mouse over the internal detail view there, you'll see on the mouse cursor feedback, hopefully, showing in the preview. that it just shows a drawing sheet next to the mouse pointer. Hopefully you can see that. If I drag my mouse over the pictorial views there, you'll see that that's got a rectangle with a white lightning bolt next to it. What that indicates is that the view is in draft quality, and if indeed I do click on that drawing view, you'll see in the display style here that that shaded view is set to draft quality. I can set that to high quality manually for a drafted view, and if I come across, you'll see that that icon has changed. Alright, so that's how we can determine whether the view's in high quality or draft quality or not. Alright, let's have a look at some more settings and tips. Okay, let's wait for that to update. Okay, so the first tip that I'd have here is that you should be using lightweight or large assembly mode in drawings. Last webinar I covered the fact that we can use those modes in the assemblies themselves. What you may not have been aware of is that you can actually use those modes in a drawing. So I'm just going to switch back to SolidWorks. And if I go to the File Open dialog, just wait for that to refresh there. File and Open. And if I click on this drawing here, you'll notice that the modes automatically switch to large assembly mode. And that's because it's detected that the number of components in this drawing have exceeded the count set in the system options to put it into large assembly mode. So if I just take a step back here and go to the system options, and we go to drawings and assemblies, you'll see that the opening large assemblies is set to a threshold of 10. Normally that's by default set to 500, but I've set it to 10 just for this example. And so it knows that there are more than 10 parts when I attempt to open that drawing, so we'll just go back to that. And so it will tell me that it can open that in large assembly mode. Okay, so that will get you into large assembly mode in that drawing, and it will apply the same sort of settings that would be applied for the large assembly being opened in as an assembly. One other thing to look at on the open dialog here as well is that we can be selective about which sheets we want to open when we're opening a large assembly drawing, particularly if it's multi-sheet. That option there gives us the ability to open all of them, and it will load them because it's got load next to it, or I can be selective about which sheets I actually want to load up. And you'll see as I've checked on the radio button for selected there, it's going to load sheet 1. If I click on this one, it will only load the BOM. If I hold down the control key, I can get it to select both of those. Or again, I can just click on one and it can be selective about which sheet it wants to open. The other sheets will be opened in quick view mode, which means they are representing only the graphics or draft quality view on there. And if you switched, let me just demonstrate that. So let's open that up. You'll see when it opens in that particular mode, This is actually been loaded, so we can see the design tree on the left hand side. If I drop my mouse over the sheet 1, generally speaking it should give you a preview. It won't actually though, because this is not loaded, so I'm just going to click on sheet 1 to go to that sheet, and you'll see that it does have the information there, but I can't actually access anything in the tree, and that's because it hasn't actually loaded that model. If I wanted to look at that model, I've got the option to right click on the drawing view and select load sheet, and then it will load that information. Because we're in large assembly mode, we can see that the drawing views are loaded up lightweight there, and they are in fact in draft quality as well. Okay, so switching back to the PowerPoint again. One other thing we can do to remove some of the strain off the drawing is just to hide detailed views that are not a work in progress. So if we've finished working on a view, we can simply select to hide that detailed view. And I've already mentioned there about the selecting sheets to load. Basically load up only what you require when you're looking at a large assembly drawing. I'll just switch back to our drawing. If you want to hide a drawing view, it's simply a matter of just right clicking. You won't see hide by default. It's actually not shown in that right click menu. You click on the double arrows at the bottom and you'll see the hide option become available. If you wish to make that available all the time, you can go to Customize menu, and you can put a check mark in there to show it all the time. Alternatively, if I just click back on the sheet there somewhere, that's drawing view number 4, I can right click on the actual drawing view there, and I've got the hide option there to hide that specific view. And so by hiding the view, it actually removes the detail and the overhead from that specific sheet. It's still there, you've just hidden it. Alright. Another option that you've got to work with large assemblies is detached drawing views. And these can be used to send a drawing without reference file. So it's a SOLIDWORKS drawing file type, SLD-DRW. But it is shown as a detached drawing document. And what this means is that it's detached itself from its references. So you don't, if you wanted to send this to another user who's using SOLIDWORKS but you didn't want to attach the assembly with it, then you can send a detached drawing. That detached drawing can actually have detail and annotations added to it while other people are editing the model, and then the drawing can be synchronized to update once it realizes that the references have been changed. The time to open a detached drawing is reduced because the model file is not loaded. The model data is not stored in memory, and that gives you more memory available to process the drawing data. The file size of a detached drawing can vary. It stores more edge data and less surface data, and as a result it's really dependent on the visible edges in the drawing. And this might seem counterintuitive, but if you've got section views on the drawing sheet, it will actually decrease the file size. If there are no sections on the drawing sheet, the file size may actually increase. Unfortunately, that's just the way it works. Continuing to view on, or to focus on views, some more tips The suggestion here is that you should use hidden lines removed in drawing views as opposed to hidden lines visible, or the wireframe type drawing views. They are more expensive in terms of the drawing rebuild times and performance than hidden lines removed are. Hidden lines removed drawing views have fewer edges to draw, and they also generate an update faster because they're not accessing that underlying information. Simplified model representations. I've already talked a little bit about configurations, but if you use configurations to simplify model detail, so a good example is bolts that have actually got threads on them. If you remove that thread detail via configuration, then at the top level it's going to have less of an impact. Configurations can actually be added from the assembly down, and if I have a look at an example of that, I'll just go back to our heater again. Maybe I'll just go for the default configuration. Wait for that to show up there. Yep. So when I'm adding configurations from the assembly, if you look at the parent-child options, which are usually hidden away, I can open that up and I can actually specify that all of these sub-assemblies and components all end up with a simplified configuration at the same time, rather than going back and individually adding a simplified configuration to all of them. You can do it directly from the assembly at the top level. Now, if you've got thousands of components, I probably wouldn't recommend doing it from the top level. You might want to break into some of the sub-assembly levels and do it from there. But yeah, you certainly have the ability to add simplified configs in bulk from the assembly level. Another tip is to turn off automatic view update and other performance options. So just going back to SOLIDWORKS again and having a look at the system options under drawings and performance. You'll see that there's an option here to allow auto update when opening drawings. If you turn that off, it will save you some significant time. I guess the proviso on using that is you should make sure that your assembly is all up to date prior to opening the drawing, and then if you do need to make any updates, you can make them manually. There is a manual update for drawing views. If I go and look at update, actually we need to be on the drawing for that. Let's just switch to the drawing. You've got the option to check for updates, and if the views are not up to date, there's an update view tool and update all views tool that you can use as well to update those views as you require them, rather than having them update automatically all of the time. Okay. The other one suggestion there is to create new views in draft mode. Obviously, we've talked about the differences between draft and quality, high quality modes for views. The suggestion there is to use draft quality mode, obviously because it takes the overhead off the drawing. With large assembly drawings, it's also recommended to save to PDF for future reference. This is, I guess, a bit more of a safety thing than anything, particularly if you're working in environments that have stability issues, you can use that PDF to refer back to if you have problems with the drawing. It gives you a bit of a history. If you're working in PDM, particularly the professional version, using PDF output can be automated, and that might be something that we can look at doing if you think that might help out. And the last tip there is performance evaluation for drawings. So if I switch back to SolidWorks, if we go to the Evaluate tab, you'll see that we've got a performance evaluation tool. This was introduced in 2016. It actually replaced the drawing statistics tool, which would have been available. And let's just do a full rebuild on that. What this tool does in the drawing environment is that it provides us drawing statistics. So the drawing statistics tool is still available as a part of the performance evaluation tool. And that gives us a bit of a breakdown about some of the information that's on that drawing view. We can actually see how many high quality views are here, how many draft quality views are here, the numbers of dimensions and notes, annotations, etc. And then back on the performance evaluation dialog, we can also see some assembly performance information, and it'll tell us if there's any items that affect that. We can go back into the large assembly model from here and then use the same performance evaluation tool in the assembly model to look at some of those issues. And I'm going to talk more specifically about the performance evaluation tool in the next webinar, specifically for assemblies. I haven't gone through that yet, but I will cover that for assemblies in the next webinar, so stay tuned for that. And then specifically for drawings, it gives us some information about rebuild times, builds of materials, those sorts of things. It does mention there that at times less than 0.1 of a second are negligible and not reported. Obviously, in a large assembly drawing, you will see some information here about some of those drawing view statistics and how long they're actually taking to propagate into the drawing when it's opened and being worked on. Okay, so that's a very handy tool for troubleshooting in large assembly drawings. Okay, so that's pretty much what I had to show today. Just to conclude, just waiting for that to show up. Yep. So we've had a look at what happens when a drawing is loaded. You know that the assembly information is loaded with the drawing and how that can impact its performance and improve the assembly mode performance, improve drawing performance. We've discussed the drawing influences affecting that performance, so views, sheets, section views, assembly cuts, etc. We specifically discussed the effects of quality settings and when it's required to use high quality, and covered a number of settings and tips which can further assist to identify and reduce performance bottlenecks in large assembly drawings. I hope this has been helpful for you. If you've got any questions, I'll be happy to take those now. It looks like there's a couple of questions from Wojtek. Do you have to set up those simplified versions of components before you can create the simplified configuration at the assembly level? No, you can push this is for Graham, you can push the simplified configuration down, so you set that up in the assembly. When you get into the part, the simplified configuration will be there, but you'll just need to set up what you want to suppress or change in those particular simplified configurations at the part level. You can't actually really determine that at the assembly level. It just sets up that configuration in the model from that part. Fraser, can a drawing be set up to a default to high quality? No, and I think one of the things that I was going to mention, if I didn't, shaded views at the very least come in as draft quality by default. If you want them to be high quality, they actually need to be changed manually on the drawing sheet. Other views, your regular orthographic views, as long as they're not shaded, if they can come in as high quality, they will. Just like to thank you for attending, and yeah, please feel free to contact me if you'd like any other questions answered.